it going, Dan?
Pretty good. How you doing?
I'm doing all right, man.
So I've heard that you've been developing an anti-cancerous treatment. What mechanisms are you looking to target/utilize for this new cancer treatment?
Yeah, well, there's a lot of emerging research coming out about the role of ubiquitination in oncogenic pathways. There's actually some emerging non-traditional roles of ubiquitination that can cause cancer. Yeah, it's crazy. Yeah, so we can go into a little background on ubiquitination first.
Yeah.
Ubiquitin's widely known. It's used, and everybody thinks protein degradation when they think ubiquitin.
Definitely.
But that's only polyubiquitin.
Mm-hmm.
There's monoubiquitin, which is involved in DNA damage repair. It's involved in endocytosis, protein quality control. There's so many different things that ubiquitin can do other than target proteins to the proteasome. It's really interesting.
That's so much more. No one talks about that. It's always about the protein degradation. So why do you think ubiquitin and cancer are related?
Well, let me tell you.
Yeah.
You see this pathway right here?
Yes.
Yeah, so this is the general way that ubiquitins are added onto proteins. So first you have free ubiquitin floating around in the cytoplasm, and that's loaded onto E1. And you can think of this as priming the ubiquitin to be added onto its substrate. And of course, because you're priming it to add it onto something, you need ATP. You need energy to kind of, load the gun here.
Definitely.
And then that's transferred onto E2. E2 is kind of just the middleman. E2 wants to transfer him onto E3.
Yeah.
And he's the important guy. He's who directs the ubiquitin onto the specific substrate. So E3s can actually be very diverse, and they really help target. And they're the real guys you need to worry about.
So there's this weird thing on this diagram I see here. What is this E4 thing?
Oh, this guy right here?
Yeah,
E4? Well, E4 is another ubiquitin ligase. And what it does is it can be independent from E3, or it can also aid in E3 function. So it can help aid in directing that ubiquitin to a specific substrate. And it's usually used when extending monoubiquitin chains to polyubiquitin chains.
So where's the cancer?
There's a couple studies coming out that are showing an emerging role of ubiquitin misregulation in cancers. And it actually turns out that E3s can be tumor suppressors or oncogenes,
Really?
depending on the enzyme's ability to degrade associated proteins.
So they can either help defend you against cancer or help cancer come into your body.
Yeah, it's crazy. And actually, E3 malfunctions
Yes.
are the second most prevalent cancer-causing agents out there.
What?
Who would have thought?
My gosh.
So there's also some other cool stuff that's going on with cancer. There's this other paper.
Yeah.
When people think polyubiquitin chains, they usually think they're hooked onto the lysine 63 chains, which usually serve non-proteolytic roles, or they're hooked on through lysine 48 chains, which target for protein degradation. But actually, the study just came out and showed that the BRCA1 BARD1 heterodimer, which is an E3 ubiquitin ligase, that can also be an oncogene. They found that it's actually linked through a non-traditional lysine. It's on lysine 6 on ubiquitin, which is the first time someone's ever seen that lysine being used. So
Are in those the breast cancer genes?
yeah.
Oh, wow. And they're involved in ubiquitin too?
Yeah, absolutely. They're actually E3 ubiquitin ligases.
Shoot, there it is again.
Yeah, it's crazy. It's just we're really realizing how much we don't know about the roles of ubiquitin.
We should definitely look into this more.
Yeah, I agree, man. Guess we should give grants to everybody.
Definitely. What is the NIH doing? That's the real question.
That is the real
Look
question.
at ubiquitin.